Hello students, in this video we are going to discuss 9.12, 9.13 and 9.14 from ray optics and optical instruments. While coming to 9.12, a person with a normal near point 25 centimeter using a compound microscope with objective of focal length 8 millimeter and eyepiece of focal length 2.5 centimeter can bring an object placed at 9 millimeter from the objective in sharp focus. What is the separation between the two lenses? Calculate the magnifying power of the compound microscope. Here, assume that this is objective and this one is an eyepiece. And an object is placed 9 millimeter from the objective. So this is the object, assume, and it is placed 9 millimeter means 0.9 centimeter. And so the objective focal length is equal to 8 millimeter means 0.8 centimeter. I am taking all the values in terms of centimeter. For eyepiece, the focal length is 2.5 centimeter. And the normal near point 25 centimeter means the final image is formed at least a distance of distinct vision we need to consider. So finally, what is the separation between the two lenses? Separation between the two lenses will be we need to write V0 plus UE. This is the formula for the separation between the two lenses. This value we need to calculate, and we need to calculate the magnifying power M value. So this M value will be for least distance of distinct vision V0 by U0. So if you take the mod here into 1 plus D by Fe, this value also we need to find out. So now here we have V0 is nothing but 25 centimeter, UE we need to find out, and U0 is given in the second one, V0 we need to find out. So we are applying objective lens for objective lens formula we are using here. So 1 by V0 is equal to, or 1 by V0 minus 1 by U0 is equal to 1 by F0. So from this 1 by V0 is equal to 1 by F0 plus 1 by U0. So F0 is 0.8 centimeter plus U0 according to the sign convention, this is a negative, minus of 1 by 0.9, that is equal to, we will get 0.9 minus 0.8 divided by 0.9 into 0.8, that is equal to 0.1 divided by 0.8 into 0.9 or 0.9 into 0.8. So from this V0 is equal to 0.8 into 0.9 divided by 0.1. So its value after simplification is 7.2 centimeter. Now we got V0 value, but we need UE. Suppose if you are applying the same thin lens formula for eyepiece, so 1 by VE minus 1 by UE is equal to 1 by FE. So from this 1 by UE is equal to 1 by VE minus 1 by FE. That is equal to, VE is nothing but distance of distinct division, least distance of distinct division, that is minus 1 by 25, minus of focal length is 1 by 2.5, so that is nothing but we have minus 1 minus 10 by 25, that is equal to minus 11 by 25. So from this UE is equal to 25 divided by 11 minus half according to sign convention, that is equal to minus 2.27 centimeter. Now while coming to the first part, the separation between the two lenses. That is equal to, we have V naught plus UE, that is equal to V naught is number 7.2 plus 2.27, that is equal to 9.47 centimeter. So this is the first subpart. While coming to the second subpart, we need to find out the magnifying power or angular magnification, that is number m naught into mg, that is v naught by ue mod, sorry, v naught by u naught into 1 plus d by fe. So if you substitute the values, v naught is nothing but 7.2 divided by u naught is from the given data itself 0.9 into 1 plus 25 divided by fe is 2.5. So that is equal to, after simplification, we will get 88. It is dimensionless. So this is the separation between the two lenses and magnifying power. So this gap is, we have 9.47 centimeter. Coming to 9.13. A small telescope has an objective lens of focal length 144 centimeter and eyepiece of focal length 6 centimeter. So what is the magnifying power of the telescope and what is the separation between the objective and eyepiece? Here the given data, objective focal length, so focal length of the objective is equal to 144 centimeter and for eyepiece is nothing but 6 centimeter. We need to find out the magnifying power. We need to find out the separation between the objective and eyepiece of telescope. For the telescope, the situation will be like this: objective will be larger and eyepiece will be smaller. So f naught is equal to 144 centimeter, fe is equal to 6 centimeter, and the objective will be at infinity. The image will be formed at the focus. So it is objective, it is eyepiece, it is nothing but f naught. And so the final image is formed again at infinity according to the given data. Magnifying power m is equal to f naught divided by fe. F naught is 144 centimeter, fe is 6 centimeter. That is equal to 24. What is the separation between them? The separation between them is and eyepiece, we have f naught plus fe. Y means the object is formed at, sorry, the image of the object is formed at f naught. Finally, so this one will be acting as like object for eyepiece. The final image will be formed at infinity. So this value is nothing but f naught plus this is nothing but fe. So that is equal to, f naught is given as 144 plus fe is given as 6. That is equal to 150 centimeter. Coming to 9.14. A giant refracting telescope at an observatory has an objective length of focal length 15 meter. So the given value objective focal length is 15 meter. If an eyepiece of focal length 1 centimeter, what is the angular magnification? That means it is objective, it is nothing but an eyepiece. That is F0 is 15 meter, Fe is equal to 1 centimeter. Therefore, here the first support A, we have M is equal to F0 divided by Fe. 15 meter means in terms of centimeter, 1500 centimeter divided by 1 centimeter, that is equal to 1500. And while coming to B, if this telescope is used to view the moon, what is the diameter of the image of the moon formed by the objective lens? Here we have to take only objective lens, we have to ignore eyepiece. And the diameter of the moon is given as 3.48 into 10 power 6 meter, and the radius of the lunar orbit is 3.8 into 10 power 8 meter. That means this is lunar orbit. It is nothing but suppose say Earth. So this value is nothing but given as 3.8 into 10 power 8 meter. We are on the surface of the Earth and the moon is here. So the situation we can take like this is objective lens. Assume that this one is a diameter of the moon and one ray is traveling like this, one more ray is traveling like this. It will pass through optic center. And its image is forming here. This is the diameter of the image and it is the lunar orbit. So this value is, suppose say if you are taking lunar orbit, this is number 3.8 into 10 power 8 meters. And when the object is at infinity, where the image will be formed, that one will be formed at focus. So here is the angle theta, here also suppose say angle theta, we can write both angles are same. Tan theta is equal to diameter of the moon divided by, so lunar orbit if you are taking suppose say R, that is equal to diameter of the image divided by the focal length of the objective. From this, the diameter of the image is equal to diameter of the moon divided by R into F0. That is equal to 3.48 into 10 power 6 divided by 3.8 into 10 power 8 into focal length of the objective is given as 15 meter it is. So we will get this value. So 13.73. So 10 power minus 2 meter it will be. So 13.73 centimeter you can get it. So this is the diameter of the image whenever we are seeing through the objective of focal length 15 meter. Thank you.